Hello friends, today I am going to speak on the topic vitamins, its structure and functions. Vitamins are a group of low molecular weight organic substances present in minute amounts in natural foods that are essential to normal metabolism, and its insufficient intake in the diet may cause symptoms of deficiency. Vitamins are not a source of energy or a building material, but mostly it functions as part of enzyme catalyzing biochemical reactions, although they have numerous other functions. Therefore, they are often referred to as essential exogenous biocatalysts. Most of the vitamins do not require digestion as they occur as small molecules. Absence of any one of the vitamins in the diet for a long period causes deficiency diseases or avitaminosis, while its excess intake may lead to hypervitaminosis, which may cause metabolic disorders. Next is the types of vitamins. The most common method of classifying vitamins is according to their solubility in water and fat, and accordingly they are divided into water-soluble vitamins, and the members are thiamine, riboflavin, niacin, pantothenic acid, pyridoxine, biotin, folic acid, cyanocobalamine, and ascorbic acid. And in the fat-soluble vitamins, the members include vitamins A, D, E, and K. Starting with the water-soluble vitamins, first one is thiamine. This vitamin is also known as vitamin B1. Thiamine is made up of a substituted pyrimidine, which is joined by a methylene bridge to a substituted thiazole. Thiamine pyrophosphate, that is TPP, is the active coenzyme form of this vitamin. This coenzyme form is also known as co-carboxylase. This vitamin, that is thiamine, has got different functions. Vitamin B1 is essential for normal growth as it acts as coenzyme in the form of TPP and is the coenzyme of decarboxylases, which take part in carbohydrate metabolism. Other two important reactions catalyzed with TPP as coenzymes are changes of pyruvic acid to acetyl-CoA and alpha-ketoglutarate acid to succinyl-CoA. Next vitamin is riboflavin. Riboflavin is also known as vitamin B2, and it is made up of a yellow pigment called flavin and a pentose alcohol called ribitone. The coenzyme form of this vitamin are flavin mononucleotide, that is FMN, and flavin adenine dinucleotide, that is FAD. The important functions of this vitamin are: it is essential for normal metabolic function of our body as it is involved in carbohydrate, protein, and fat metabolism, either as FMN, that is flavin mononucleotide, or FAD, that is flavin adenine dinucleotide. Few examples being: FMN is an important constituent of electron transport chain, and FAD is involved in dehydrogenation of succinic acid. It is also involved in the synthesis of visual purple pigment, that is rhodopsin, of rod cells of the retina. Next vitamin is niacin. Niacin was formerly known as PP factor, that is pellagra preventing factor, and vitamin PP is a common name for nicotinic acid, and its amide, nicotinamide, also formerly known as vitamin B3. The two forms, namely nicotinic acid and nicotinamide, are collectively called niacin. Nicotinamide forms a part of two very essential coenzymes, nicotinamide adenine dinucleotide, that is NAD, and nicotinamide adenine dinucleotide phosphate, that is NADP. The important functions of this vitamin are: it is involved in the metabolic pathways consisting of biological oxidation reduction reactions. It also participates in metabolism either as NAD+, that is nicotinamide adenine dinucleotide, or NADP, and acts as hydrogen acceptor in dehydrogenation reactions. Next vitamin is pantothenic acid. This vitamin is also known as vitamin B5 and is an amide of pentoic acid and beta-alanine. It combines with adenosine diphosphate, forming phosphodiester bond. This in turn is joined to beta-mercaptoethylamine through an amide linkage. The coenzyme form is known as coenzyme A to denote its role in acetylation reactions occurring in fatty acid synthesis and oxidation. It also takes part in other metabolic transformations. The important function of this vitamin are: it participates in metabolism by serving as acyl carrier. For example, acetyl-CoA is the pivot of Krebs cycle, so is essential for oxidative metabolism. Also, succinyl-CoA is involved in the synthesis of hemoglobin. Next vitamin is pyridoxine. Pyridoxine is also known as vitamin B6. Substitution at position C4 of the pyridine ring by different groups leads to the formation of three forms of vitamin B6. The formyl derivative, that is 4-formyl 3-hydroxy-5-hydroxymethyl 2-methylpyridine, is called pyridoxal. The hydroxymethyl derivative, that is 3-hydroxy-4,5-bis hydroxymethyl 2-methylpyridine, is called pyridoxine or pyridoxal, and the amino-methyl derivative, that is 4-amino-methyl 3-hydroxy-4-hydroxymethyl 2-methylpyridine, is called pyridoxamine. The coenzyme form of this vitamin are pyridoxal phosphate and pyridoxamine phosphate. The important functions of this vitamin, that is pyridoxine, are: in general, pyridoxal phosphate, that is PLP, acts as coenzyme of transaminases and thus accelerate the metabolism. For example, the enzyme transaminases is involved in the reaction, that is alanine, when reacts with alpha-ketoglutarate plus PLP. In presence of the enzyme alanine transaminases, it forms pyruvate plus glutamic acid. This vitamin is also involved in tryptophan metabolism, glycogenolysis, and erythropoiesis. Next vitamin is biotin. Biotin is also known as vitamin B7 or vitamin H and is an imidazole derivative. Biotin is bound in enzymes through an amide bond provided by the epsilon amino group of lysine as the so-called N-carboxy biotinyl lysine. The important functions of this vitamin, that is biotin, are: it is involved in many carboxylation and decarboxylation reactions. For example, conversion of pyruvic acid to oxaloacetic acid, and also the carboxylation of acetyl-CoA to form malonyl-CoA in fatty acid synthesis. Next vitamin is folic acid. Folic acid is also known as vitamin B9 or vitamin M. Folic acid is composed of three major components. These are a substituted pteridine, para-aminobenzoic acid, and glutamic acid. Hence, it is also known as pteroyl glutamic acid. 5,6,7,8 tetrahydrofolic acid, that is FH4, is the coenzyme form of folic acid. The important functions are: it acts as coenzyme for the synthesis of those proteins which are essential for formation and maturation of RBCs. It promotes the synthesis of thymidyllic acid and DNA. Next vitamin is CYANOCOBALAMINE. This vitamin, that is CYANOCOBALAMINE, is also known as vitamin B12. It has a very complicated structure in which cobalt-3 atom is bound to 4 nitrogen atoms of a corine ring, a nitrogen atom of 5,6-dimethyl benzimetazole moiety, and a cyanide group. In one of the coenzyme form of this vitamin, the cyanide group is replaced by a 5-deoxyadenosyl group. The important function of this vitamin is it is essential for formation and maturation of RBCs. Next vitamin is ascorbic acid. Ascorbic acid is also known as vitamin C. Ascorbic acid is an enediol of a hexose sugar acid and is a naturally occurring lactone. This is the reduced form of the vitamin, the oxidized form being dehydroascorbic acid. The important functions of this vitamin are: the functions of ascorbic acid are related primarily to its redox properties. In plants, it plays a role in photosynthesis by regulating the amount of active oxygen species and also acts in the growth and differentiation of cells. In animals, ascorbic acid is involved primarily in hydroxylation reactions ongoing in the body. Vitamin C also participates in the biosynthesis of monopolysaccharides, etc. It also has the protective function for the labile form of folic acid. This is a table showing water-soluble vitamins, its sources, daily requirements, and deficiency symptoms. Vitamin B1. Its important sources are whole grains, yeast, meat, eggs, green vegetables, etc. And the daily requirement is 1.2 to 1.4 milligram. Its deficiency causes beriberi. Next vitamin is vitamin B2, that is riboflavin. The important sources are milk, meat, green vegetables, etc. And the daily requirement is 1.4 milligram in adult. its deficiency causes cirrhosis. Vitamin B3, that is niacin. The important sources are milk, fish, yeast, meat, green leafy vegetables, etc. And the daily requirement is 13 to 18 milligram. Its deficiency causes pellagra. Next vitamin is vitamin B5, also known as pantothenic acid. And the important sources are liver, milk, eggs, green leafy vegetables, etc. And the daily requirement is 5 to 10 milligram. Its deficiency causes dermatitis in chicken and early aging in men. Next vitamin is vitamin B6, and the important sources are fish, liver, kidney, eggs, cereals, green vegetable, fruits. And the daily requirement is 2 milligram. Its deficiency causes convulsion in children. Next vitamin is folic acid, and the important sources are green leafy vegetables, nuts, intestinal bacteria. And the daily requirement is 0.5 milligram. And the deficiency causes microcytic anemia. Next vitamin is vitamin H, liver, milk, eggs, vegetables, fruits. Its deficiency causes dermatitis, muscular pain, growth failure. Next vitamin, that is vitamin B12, and the important sources are eggs, liver, kidneys, fish, milk, seafood, etc. And the daily requirement is 1.2 milligram. Its deficiency causes pernicious anemia. Next vitamin, that is vitamin C, and the important sources are citrus fruits, green leafy vegetables, green peppers. And the daily requirement is 50 milligram. Its deficiency causes scurvy. Next, we will proceed to fat-soluble vitamins. Fat-soluble vitamins are oily in nature and are soluble in organic solvents but insoluble in water. And these vitamins include vitamin A, D, E and K. Let us start with the vitamin A. Vitamin A is an isoprene derivative which is related to carotenoid pigments, that is alpha, beta and gamma carotene found in plants. These carotenoid pigments are precursors of vitamin A and are known as provitamin A. Vitamin A contains a 6-member carboxylic ring and a polyunsaturated 11-carbon side chain. The important functions of this vitamin A are: it is involved in the synthesis of mucopolysaccharides, important for body growth. It maintains integrity and secretory activity of epithelial granular cells. Retinol, that is vitamin A aldehyde, combines with opsin protein to form rhodopsin, that is visual purple, of rod cells of retina, essential for night vision. Next is vitamin D. There are two main compounds which are known for their vitamin D activity, namely calciferol and cholecalciferol. Calciferol or vitamin D2 is produced by the UV irradiation of ergosterol present in yeast and molds. And cholecalciferol or vitamin D3 is produced by the UV irradiation of 7-dehydrocholesterol present in the skin. The important function of this vitamin, that is vitamin D, are vitamin D mainly helps in calcium, phosphorus balance in the body fluids. It also increases absorption of calcium from the intestine, so is necessary for formation of healthy bones and teeth. Next, we will proceed to vitamin E. Vitamin E belongs to a group of compounds called tocopherols. Among the tocopherols, alpha tocopherols is the most important of these, both in terms of availability and effectiveness. The important functions of this vitamin, that is vitamin E, are vitamin E, it acts as an antioxidant and prevents oxidative destruction of other vitamins like vitamin K. It also prevents formation of unsaturated fatty acids and hence preventing brown pigmentation. It is also essential for normal working of gonads, continuation of pregnancy and normal childbirth, and also it removes wrinkle formation on skin, scars, etc. And last vitamin is vitamin K. This vitamin, that is vitamin K, is derived from 1,4-naphthoquinone. And the important function of this vitamin, that is vitamin K, are vitamin K is essential for the formation of prothrombin from cells in liver and hence help in blood coagulation. It is also said to participate in the phosphorylation reactions of photosynthesis in plants and probably has a similar role in the electron transport system in animal tissues as well. This is a table showing fat-soluble vitamins, their sources, daily requirements and deficiency symptoms. Vitamin A, the important sources are fish, milk, liver oil, eggs, butter, green vegetables, carrots. Daily requirement is 2 mg. Its deficiency causes xerophthalmia, night blindness, keratomalacia, retarded growth. Next vitamin is vitamin D. The important sources are fish, liver oil, lipid animal sources, also form in the skin in the presence of UV rays. Daily requirement is 0.01 mg. Its deficiency causes rickets in children, osteomalacia in women. Next vitamin is vitamin E. The important sources are vegetable oils, green vegetables, seafood, egg yolk. Daily requirement is 15 mg. Its deficiency causes reversible sterility in rats. Last vitamin is vitamin K. The important sources are green leafy vegetables, pork liver, cauliflower, intestinal bacteria. Daily requirement is 0.07 to 0.14 mg. Its deficiency causes hemorrhage. To conclude, vitamins are either fat-soluble or water-soluble. It can be ascertained that water-soluble vitamins play important function in the body by acting as coenzyme, that is vitamin B, in collagen formation, as antioxidant, in protection from free radical damage, vitamin C, whereas fat-soluble vitamin act as an anti-infective agent, that is vitamin A, in mineral metabolism, especially calcium and phosphorus, that is vitamin D, as antioxidant in protection from free radical damage, vitamin E, and blood clotting, vitamin K. Fat-soluble vitamins are stored in body fat, while water-soluble vitamins are used or quickly excreted in urine. Most vitamins cannot be produced by the body and so must be directly obtained from food. Our body needs the vitamins in small amounts. Some of the vitamins, such as vitamin A and vitamin D, if taken in excess, can cause hypervitaminosis. However, deficiency of vitamins was one of the important causes of diseases and death in earlier times and continued to be so in many parts of the world. So, the recommended amounts of the vitamin are to be regularly obtained from food sources.